Okay, everyone, so we're going to look today at circuits, a little bit more in depth about different types of circuits. So in general, there's two kind of categories that circuits can fall under: a series circuit and a parallel circuit. And actually, you've heard me say these words before, because when we looked at voltmeters and ammeters, we talked about them being able to be connected in series or in parallel. And that'll make more sense as we go through this today. So we're going to look at series circuit first, and then we're going to do parallel circuits, and then you guys will have some practice questions to do, and we'll take those up at our next meeting. Okay, so series circuit. So a series circuit in general, like the main way to know that you have a series circuit is it's a circuit that has only one pathway for the electrons to flow. So meaning there is only one option that the electrons have. The current flows only in that one pathway. Okay. Now the current at any point on the series circuit is always the same. This will make sense when we do some examples together. The potential difference, though, is actually a sum of the potential difference of the battery. So these last 2 points won't make a ton of sense until we start looking at some pictures. But the main thing I want you to know is when you're looking at a circuit, how can you know we have a series circuit? There is only one pathway. So for example, let's say I have a 2-cell battery here. Okay. So here is a circuit, right? So the electrons are going to flow out of this battery into this light bulb, into the next light bulb, into this resistor, and then back into the battery. So notice how there is only one option for those electrons to travel in. They're traveling on this line. There's only one line, okay? I'm just going to show you an example of something that is not a series circuit, just so you can see the difference. Okay, so here's an example of something that is not a series circuit. So I want you to notice something. When the electrons hit this point, it's almost like there is a fork in the road. So electrons can travel down this pathway, or it can travel down this pathway. Okay, and then back around. So because there is this fork in the road where electrons have a choice, not a choice, but they basically split up, some electrons go forward, some electrons will go down, this is not in series. This is called parallel, which is the second type of circuit. Here, there is no option. There is only one pathway for those electrons to follow. There's no fork in the road. So this is a series circuit, because that's the main difference. Fork in the road, parallel. No fork in the road, series. Okay, there's only one pathway. So multiple pathways, parallel. One pathway, series. Okay, so here's a general rule for those last points that we were talking about. So first of all, you're going to see this symbol quite a bit. IS, so remember the symbol for I is current. The symbol for potential difference is a V for voltage, right? So if you see IS or IT, this represents the battery. So it's like the source current, so the electrical source, which is our battery, or sometimes it's referred to as the total current. So the total current or the source current is always the battery. Okay, so for example, if you look at this circuit here, right, here we have our electrons are traveling out of the negative terminal into the positive terminal. Notice there is only one pathway for those electrons to travel. So this is a series circuit, right? Now, notice here it says IS. That means this is the current of the electrons coming out of the source. So the electrons here have 12 amps. So in a current, if we're looking at current in a series circuit, the current is always the same. So meaning the current at any point, so if I measure the current here, or here, or here, or here, anywhere in this circuit, The current is always exactly the same because there is only one pathway. So the number of electrons over here is going to be the same number over here. The electrons have nowhere else to go. They're traveling along this circuit. So this is not really like I know it says formula. It's not really like a formula where you plug numbers in. It's just showing you the relationship. So this means that basically it does not matter where you measure the current will always be the same in a series circuit. So remember, we're talking about a series circuit here. So what does that mean for us for current? Well, if it's 12 amps at the battery, that means the current over here is also 12 amps. The current over here is also 12 amps. And the current over here is also 12 amps. They're always the same in a series circuit. Okay, so current in a series circuit is always the same. So I'm going to change the color I'm using just so we can look at voltage. So let's talk about voltage. Actually, maybe it's better if I just clear out this. Okay. So voltage works differently in a series circuit. Okay, so if you notice, so same thing, Vs or Vt, total voltage or source voltage, that's referring to the voltage of the battery. Okay, now if you remember what we talked about when we looked at voltage, you'll remember that the total voltage of the battery is really like how much energy those electrons have to spend in a circuit. Right? The analogy we use is like kind of like they're traveling around the circuit and they have money to spend, and the battery money is like the money that it has when it leaves, and then when it comes back, it's gone. So how voltage works in a series circuit is you have to think about all the different loads that are on the pathway. So for example, this first load that the electrons will meet uses 2 volts worth of energy. So you have to think, when the electrons pass through here, 2 volts worth of energy is used. As they continue on, this load uses 6 volts of energy. So far it's used 2 and then 6 volts, right, for a total of 8 so far. And of course, as it continues on, the third load that's here is also using 2 volts. So when you have to look to see, well, how much voltage is the total circuit using, really what you do is you add up all of the loads that you have, because it's telling you, okay, well, 2 volts was spent here, 6 volts was spent here, and 2 volts were spent here. So the total that's being used from when it leaves the battery to when it comes back is going to be 10. 2 plus 6 plus 2 is 10 volts. So when you're looking at a series circuit and voltage, you have to think, how many loads did those electrons pass through, right? So this passed through 1, 2, 3 loads. That means the total energy spent has to be those 3 loads added together. So I know this is showing you just 1, 2, 3, but maybe you have 5 loads or 6 loads. It doesn't matter how many there are. You still have to look at the total amount that those electrons are passing through to see how much energy was used up. Okay, so let's look at another example before we get to parallel circuit. So let's say we had a 2-cell battery, a light bulb, a resistor, and let's say that's it. We have a closed switch. Okay, so let's say we had some information. Maybe I have current here being 2 amps. My voltage, I don't know. Here I have voltage being 3 volts, and my current, I don't know. Here, my current at the battery, I don't know. And my voltage at the battery, let's say I had 10 volts. Okay? Now, whenever you're asked to solve questions like this, where some information is given and some isn't, you will always have enough information to solve what you're looking for. Okay? So, first of all, you want to sit and realize, okay, this is a series circuit, right? So one pathway. Now, automatically, because you have a series circuit, what should be running through your head is that current is always the same. So because even though we don't have current over here, because we have one current number given, really that means that we are given all the currents. 2 amps, 2 amps. Because remember, current does not change. Okay? Now, voltage is additive. So meaning this number here, this 10 volts at the battery, is telling us the amount of energy the electrons have spent in the circuit. So as the electrons travel through this load, they've spent 3 volts. Now, because there's only one other load, that means that the rest of the energy has to be spent right here. So if we have 10 volts total, and we've spent 3 volts at this light bulb, that means the remaining 7 had to have been spent at this resistor, right? So because they have to add to the same total value, you can figure out what's left over by subtracting and seeing what is remaining, right? So if we have 10 total, these two should add up to 10, right? All of the loads should add up to the number that's at the battery. Okay, so you'll have some practice work with this. We're very similar to this type of question where you'll have some that are missing. And but remember, you'll always have enough info that you'll be able to solve for what we're looking for.